just be a comet. A renowned theoretical physicist is pushing the possibility that it could be a nuclear-powered spacecraft.
Something strange is happening in deep space. A wandering interstellar object called 3I Atlas, once dismissed as just another icy rock, has begun spewing metal, and not in small amounts. Now its projected path crosses dangerously close to Mars.
So when you hear it's passing by Mars at a great distance.
Officially, there's no cause for alarm. Unofficially, the question echoing through control rooms is darker. What if this object isn't just passing through? What if it's aiming for Mars, and what happens if it doesn't stop there? Night of the Metal Surge. It began as a quiet, uneventful night above the Atacama Desert. The skies were clear, the air still, and the instruments at Chile's Very Large Telescope, VLT, were running smoothly. No solar flares had been reported, no magnetic storms were expected, and nothing unusual appeared in any of the data forecasts. Then, just after midnight, something unexpected flashed across the telescope's digital spectrum feed, a narrow cluster of bright lines that hadn't been there before.
Looking at the life cycle of certain patches of the sky, we're also looking to see other pulsating stars, things like that.
To anyone outside the observatory, that would sound trivial. But to an astronomer, emission lines are the fingerprints of atoms in space. Each element emits light at specific colors or wavelengths when it's excited by heat or radiation. The VLT's instruments were tracking 3I Atlas, the third known object ever to enter our solar system from interstellar space.
3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system.
The team expected to see the usual pattern for a cold, rocky traveler like weak traces of gases or frozen water vapor. Instead, they saw something completely different. The lines corresponded to nickel, a heavy metal that shouldn't appear in significant amounts at such a distance from the sun. At first, the team dismissed it as a random glitch, but within minutes, the pattern grew clearer and stronger. The nickel emissions didn't fade, they intensified, quadrupling in brightness over the span of an hour.
This is actually a dense cloud of dust that somehow did not produce until recently a tail.
By sunrise, the same pattern appeared halfway across the planet. Japan's Subaru telescope in Hawaii confirmed the anomaly. Two separate observatories on opposite sides of Earth recorded the same signature at the same time. The readings matched perfectly. A sharp, sustained spike in nickel levels, while iron, its chemical twin, remained almost completely absent. That imbalance was scientifically impossible. In nature, nickel and iron are created together in the same supernova explosions that form planets and stars. To see one without the other, and to see it growing stronger overnight, was like watching fire burn underwater.
This was a really dramatic difference from what had been seen previously.
The VLT team had already flagged 3I Atlas months earlier for its strange chemical makeup. It had shown traces of metals where only ice and dust should be. But this flare was different. It wasn't random or noisy. It was smooth, timed, and alarmingly clean, as if whatever was happening inside the object followed a deliberate rhythm. The spike began exactly as Atlas crossed a heliocentric threshold, the point where sunlight begins to heat an object as it moves closer to the sun. By dawn, NASA's Planetary Defense Coordination Office, PDCO, and the Jet Propulsion Laboratory, JPL, had been alerted. The incident log moved from routine monitoring to rapid capture status, a protocol reserved for threats or unexplained phenomena.
It turns out that the two directions of the WOW signal and 3I Atlas are aligned.
Every available observatory on Earth and in orbit was ordered to track 3I Atlas in real time. Internal notes reportedly read, "Capture every subsequent spike." Do not stop recording teams began cross-checking their systems, line by line. They looked for false readings, reflections from satellites, or interference from the atmosphere. They found none. The signal was real. Something inside 3I Atlas was releasing metallic vapor at a rate far beyond anything seen in a natural comet or asteroid. That single fact sent shockwaves through the astronomy community.
It's moving too quickly to have come from the outer reaches. It's from someplace else.
Nickel is not a gas that evaporates easily. For it to appear in visible quantities, the interior of Atlas would have to reach thousands of degrees Kelvin, temperatures hotter than molten lava. But the object was too far from the sun for that to happen. It should have been frozen solid, colder than any glacier on Earth. Nothing in standard comet physics could explain it.
it still would be almost impossible to see it with your own eyes. It's just that dim.
The term metal flare began appearing on private astronomy channels. Some scientists suggested that sunlight might be triggering chemical reactions beneath Atlas's surface, releasing pockets of molten metal. Others speculated about micro-impacts or electrical discharges, like lightning trapped inside rock. But even these ideas couldn't explain the precision of the event or the regularity of the bursts.
But in all cases, it has nothing to do with the cylindrical shape of the source.
By the end of the week, every independent telescope confirmed the same thing. The surge was not an illusion or a software error. It was happening over and over again, like a pulse. 3I Atlas was releasing metal in waves that was bright enough to burn across the spectrum like a heartbeat. What startled scientists most was not the brightness, but the behavior. It was too organized. It didn't look like an explosion or a random burst of heat. It looked active, as if the object was responding to the sunlight, breathing metal with every turn. For the first time, some researchers began to wonder if they were observing something far stranger than a comet. Whatever 3I Atlas was, it wasn't behaving like an ordinary visitor from another star. And what the telescopes captured next would turn speculation into fear. The unnatural chemistry that underpins it. Back when the James Webb Space Telescope first turned its gaze toward 3I Atlas, scientists expected a familiar chemical profile. They expected to find traces of frozen water, carbon monoxide, and possibly a little methane or ammonia. What they got instead was a dataset that defied every known pattern. The comet's coma, which is the hazy envelope surrounding its core, was overflowing with carbon dioxide, yet almost devoid of water vapor. The ratio was roughly 8-to-1, an imbalance so extreme it left researchers rechecking their calibration files in disbelief. In known comets, water dominates everything. It's the engine of their tails, the heart of their bright plumes. Even in distant carbon-heavy bodies, the ratios rarely tilt past 2 or 3-to-1. But 3I Atlas wasn't just leaning toward CO2, it was built from it.
Third object ever confirmed to have come from interstellar space.
Webb's infrared sensors showed clear, structured emission lines for carbon dioxide ice sublimating off its surface, while the usual fingerprints of H2O barely registered. The readings implied that the gases weren't venting from shallow frost. They were coming from deep internal layers of ancient materials buried beneath kilometers of frozen rock and dust. These were possibly remnants from another star's planetary system. Then came the numbers from Chile. The VLT's high-resolution spectrograph revealed something even stranger. The nickel output didn't rise linearly with sunlight, it exploded exponentially. Mathematically, the nickel release scaled with the inverse of distance from the sun raised to the 8th power, meaning that each step closer to the sun resulted in a greater nickel release. Sun multiplied the emission by massive amounts.
To an unusual object speeding through our solar system.
That curve made no physical sense. Normal solar heating should produce a gentle, smooth ramp-up, not a vertical spike. This single measurement sent theorists into a frenzy. Some proposed that Atlas's metals were locked inside complex molecules, perhaps nickel bonded with carbon compounds like metallic organic salts. As solar radiation hit them, these compounds might have shattered apart, releasing nickel vapor in sudden, violent bursts. Others compared the readings to industrial exhaust, like a vented system releasing built-up pressure in pulses rather than a constant stream. A smaller, more speculative camp took the idea further. They pointed out that certain nickel-rich minerals only form under extreme pressures and temperatures, the kind you'd find deep inside planets, not floating between stars. If 3I Atlas carried those minerals, then it wasn't a simple comet. It could be a fragment of a shattered world, ejected from a system where the chemistry and geology were utterly alien to us.
3I Atlas, the interstellar mystery getting weirder by the day.
Even mainstream researchers began using cautious language. Phrases like non-terrestrial mineral formation conditions and volatile metal coupling appeared in private papers. The chemistry was still bound by physical laws, but it played by rules no one on Earth had ever seen before. The deeper the analysis went, the more unsettling it became. The CO2-rich coma meant that water, the universal marker of cometary life cycles, was not the main driver here. That, in turn, meant the tail's formation and activity were powered by something else entirely. Nickel atoms weren't supposed to be released this way. They required temperatures higher than molten rock, and yet there they were, glowing in ultraviolet wavelengths, thousands of degrees hotter than any reasonable comet core could sustain. Some observers speculated that Atlas might be generating its own heat through radioactive decay, a kind of built-in energy source. Others floated an even wilder idea that the nickel wasn't being created or released naturally at all, but reprocessed from internal mechanisms we simply didn't understand. Still, the official line remained grounded.
Interstellar object ever detected passing through our solar system.
NASA and the European Southern Observatory both urged caution, emphasizing that unknown chemistry doesn't automatically mean artificial design. Yet privately, several analysts admitted that Atlas's emissions looked too patterned, almost timed, with each flare occurring at intervals that lined up with solar flux cycles. That rhythmical pulse of metal made 3I Atlas feel less like a drifting rock and more like a system. And that was the turning point, because when the data teams plotted those emissions against the object's path, a new pattern emerged that hinted not only at impossible chemistry, but at intentional motion. Trajectory too precise, metal too wild. Astronomers had been tracking 3I Atlas across the inner solar system, expecting a routine inbound arc, a long, lazy curve past the sun before being slingshotted back into the dark. But the numbers refused to stay normal. Atlas was moving at 255,000 kilometers per hour, far faster than comets of its size or mass usually travel. That kind of velocity required something more than a simple gravitational assist. And yet that seemed to be exactly what it was doing, or pretending to do. As its path was plotted, researchers noticed an eerie precision. The object's orbital plane matched almost perfectly with that of the inner planets. It wasn't diving in at a random tilt the way interstellar bodies like Oumuamua had. It was gliding along the same flat plane that Earth, Mars, and Venus occupy.
Trajectory. This is 3I Atlas. This is Mars. 3I Atlas is about to swing by, and a fleet.
This was a coincidence so rare that one astronomer called it engineered luck. Then came the real twist. When Atlas swung past Venus, its angle of approach and exit mimicked a textbook gravity assist, like the kind human probes use to gain speed. The same pattern appeared again near Mars and Jupiter, as every pass gave it a small, precise boost. The odds of 3 natural flybys aligning so cleanly, independent trackers later calculated, were roughly 1 in 20,000. If Atlas wasn't being actively guided, then how was it managing such control? Some suggested that the nickel flares, which continued to erupt at strange intervals, might be tied to these course bends. In one striking data set, a nickel surge occurred less than 48 hours after each major trajectory change, as if something inside the object was adjusting thrust or venting energy right after each maneuver. NASA, of course, maintained a cautious tone. Publicly, the agency has always described Atlas's orbit as stable but under review. But behind closed doors, internal memos reportedly described its movement as too consistent, too smooth, too aware. That phrasing alone set off a firestorm of speculation online. Some scientists tried to cool the rumors, insisting it was all coincidence. Others weren't so quick to dismiss it. "You can explain one coincidence," one analyst said in a private interview, "but not a chain of them that all line up with energy spikes."
He's talking about this 3I Atlas as actually being literally an alien ship.
The unease deepened when orbital models showed that in late October 2025, Atlas would pass directly behind the Sun from Earth's point of view, giving a blackout window lasting nearly 2 weeks.
So on October 3rd, 3I Atlas will pass within 29 million kilometers.
During that time, every telescope, radar array, and tracking system on Earth would lose sight of it. That gap, some whispered, would be the perfect moment for a hidden trajectory correction that no one could confirm or deny until it reappeared. NASA planned continuous monitoring on both sides of the blackout period. Still, a few insiders hinted that the agency was preparing for surprises, quietly expanding the observation budget and allocating emergency analysis teams. The pattern now looked like a stable, accelerating, deliberate path with timing matched with metal emissions and maneuvers that mirrored human flight mechanics. Whether it was intentional or natural remained an open question, but to many following the data, 3I Atlas no longer seemed like a drifting visitor. It was moving with purpose. For the first time, serious researchers were no longer laughing off the possibility of a self-guiding interstellar object. They were watching it closely, which led to the strangest question of all. What if those metal bursts weren't natural exhaust, but deliberate control? Camouflage or engine? The probe hypothesis. By now, 3I Atlas had crossed from scientific curiosity into a strange puzzle that no model could fully solve. Every observation added another layer of unease. The metals it vented, the precision of its orbit, and the timing of its surges all looked deliberate. That was when an old idea resurfaced, one proposed years earlier by Harvard astrophysicist Avi Loeb. If an advanced civilization wanted to send probes across the stars, they might hide them as comets. According to Loeb's logic, a comet-shaped craft would be the perfect disguise. Ice and dust would shield the core from cosmic radiation and micrometeoroids. The natural-looking tail of vaporized gases would mask any heat signature that might give it away. From a telescope's point of view, it would look indistinguishable from a frozen rock, even if something inside was awake. With 3I Atlas, the theory suddenly seemed less far-fetched. Its nickel bursts and strange rhythmic spikes of metal vapor began to look less like random geological events, and more like pressure releases or thermal dumps that an outflow a machine might use to manage internal heat.
Whether the object is of that size or maybe much smaller and surrounded by a cloud of dust.
In this view, the spikes weren't just chemical reactions, they were part of a controlled process, either cooling, venting, or propulsion. Then came another anomaly. Instruments monitoring the plasma surrounding Atlas detected unusual ripples and current patterns. Some early data hinted at electromagnetic fluctuations that didn't line up neatly with the direction of the solar wind. It almost looked like the object was generating its own magnetic field in a kind of shielding bubble around itself. NASA's official line was simple: solar wind distortion. But not everyone was convinced. To some, it resembled the magnetospheric shaping seen in theoretical propulsion systems. If this interpretation were true, and that remains a massive if, then Atlas was not disintegrating under the sun's heat. It was activating. The closer it got to the sun, the more metal it vented, the more plasma it interacted with, and the smoother its trajectory became. To skeptics, that was a coincidence. To others, it was a response. Still, no hard proof exists. Every strange observation can be explained by more traditional science: volatile rich ice pockets, photochemical breakdown, or the unknown chemistry of interstellar minerals. The plasma ripples could be turbulence. The nickel surges could be from internal stresses cracking open buried metal veins. The precise orbit could simply be a product of initial velocity. And yet, the coincidences stack up. Each explanation bends, and each one just barely fits. As one astronomer put it, it's not that we can't explain Atlas. It's that every explanation sounds slightly wrong. The line between natural and artificial has never felt thinner.
And it's only the third object ever confirmed to have come from interstellar space.
To many researchers, 3I Atlas has become a test case reflecting our limits in understanding alien physics. If it is natural, it's teaching us new chemistry. If it isn't, then something intelligent built it long before we were watching. For now, the scientific community walks a tightrope between evidence and imagination. No one dares call it a probe, but no one can rule it out either. But whatever its purpose, its path now points near one world: Mars, and that's where the stakes turn deadly serious. By October 2025, NASA's official stance remained calm. The agency's public forecast placed 3I Atlas's flyby of Mars at 0.19 astronomical units, which is about 28 million kilometers away, and a wide miss by all planetary defense standards. On paper, that should have been reassuring. But inside tracking circles, the tone was changing. The problem wasn't where Atlas was now, but how fast its orbit confidence was falling. Each nickel surge seemed to throw off the models a little more. Data from the Jet Propulsion Laboratory's Sentry system began showing what scientists call a growing uncertainty cone, which is a spread of possible future positions that widens the farther ahead you project. Normally, this happens because of small measurement errors, but with Atlas, the cone was growing much faster than expected. In simple terms, it meant even a tiny change in motion could now lead to a very different outcome.
Such a big object would actually be almost resolved by the high-rise cameras.
For an object moving at 255,000 kilometers per hour, a course shift of just 0.01 degrees could translate to a missed-distance change of millions of kilometers by the time it passed Mars. And that's before accounting for the strange metal ejections that appeared to act like bursts of thrust. This was what made NASA's Planetary Defense Coordination Office, PDCO, take notice. According to leaks from within the European Space Agency and the Minor Planet Center, the PDCO had quietly begun running the kind of simulation drills used to estimate impact risks and fragmentation patterns. Mars appeared in several of those what-if scenarios. The reasoning was simple. If Atlas was shedding metal or reacting in unpredictable ways, its center of mass might be shifting, altering its orbit just enough to nudge it closer to Mars's gravity well. Even a small fragment could pose a major problem. At that speed, a piece no larger than a car could hit Mars with the energy of several megaton-class explosives. Then came the most unsettling reading yet. In late September, several independent observatories recorded what looked like a drop in velocity. It was tiny, only a few meters per second, but enough to raise eyebrows. It happened right after another nickel burst. Some interpreted it as a sensor error. Others called it a drag anomaly, the kind of slowdown that could occur if the object released material backward like a reverse thrust. NASA officials publicly dismissed the finding, still saying Atlas's orbit remained stable but under review.
NASA were to greenlight a mission. What are the measurements or data that you would need returned?
But multiple insiders later told reporters that mission teams were already rehearsing Mars contingency procedures, including deflection simulations and debris mapping. They weren't expecting an impact, but they weren't betting against one either. Behind closed doors, several planetary scientists admitted something uncomfortable. No one could fully predict Atlas's next move. Its composition, its surges, and its unexplained velocity dips were rewriting standard models in real time. The more data they collected, the more unpredictable it became. Even if the probability of a Mars impact stayed below 1%, it was no longer zero. And in orbital mechanics, when you cannot rule out a collision, you prepare for it. NASA may still call an impact extremely unlikely. But extremely unlikely is not the same as impossible, and right now, the people watching Atlas the closest are planning for the unthinkable, because the alternative is to be caught off guard. With Mars now within the margins of possibility, the next wave of data may reveal where it might be coming from. What rising metal emissions tell us about alien worlds. Every nickel flare from 3I Atlas acts like an X-ray of its interior and the materials buried beneath its frozen crust. For astronomers, these metal emissions are not just strange lights in space. They are chemical fingerprints that could reveal where this object came from and what kind of star once forged it.
And then it will move on to the next star along its path. And if it has been doing that...
The numbers don't fit anything known in our solar system. In normal comets, trace metals like nickel and iron appear in roughly equal proportions. But in Atlas, the ratio is heavily skewed toward nickel and cobalt, with barely any iron in sight. Spectral readings from the Very Large Telescope and the James Webb Space Telescope confirm that imbalance. This isn't just unusual, but unprecedented. That ratio has led to a bold, but scientifically grounded hypothesis. Atlas may not be a comet at all, but a fragment of a destroyed planet's metallic core. In some distant system, a massive collision or stellar explosion could have torn that world apart, scattering molten metal across space. Over time, some of that material may have cooled, frozen, and been kicked free into interstellar drift. If true, then Atlas is not just a visitor, but a geological relic of another sun. The idea makes sense, in part because heavy elements like nickel, cobalt, and chromium are forged in the deaths of stars. A planet that formed near a metal-rich sun would naturally have higher concentrations of these materials deep inside it. So, when 3I Atlas releases nickel vapor, scientists might be watching the same process that once occurred in the heart of alien planets, long before they were destroyed. Still, that's only the realistic side. The speculative side, stirring quiet debates inside NASA and the European Space Agency, asks if these flares might mean something more. Some researchers have noted that the nickel surges don't follow random timing.
The European Space Agency has released images showing the interstellar object believed to be a comet.
They appear to rise and fall with an almost rhythmic consistency, as if responding to internal regulation rather than just sunlight. If Atlas truly were an artificial construct, as a few theorists have dared to suggest, then the metal emissions might serve as thermal control systems, similar to how spacecraft vent excess heat. In this view, the object's internal nickel outgassing could be a deliberate part of an engineered process to maintain structure, stabilize spin, or even maneuver through space. There's no hard evidence for that, only pattern recognition that seems too neat to ignore. What's certain is that every burst carries meaning. Each flare helps researchers piece together how interstellar debris behaves, how metal-rich worlds evolve, and how star systems beyond our own might look inside. Even if Atlas is purely natural, it has already changed how astronomers define a comet, forcing them to reconsider where the line between rock, relic, and machine might be drawn. For NASA, the stakes are no longer academic. If these nickel emissions truly affect Atlas's orbit even slightly, then understanding their cause could mean predicting its future path. And that path, for now, points uncomfortably close to Mars. Because behind every scientific explanation, there's one question mission planners can't ignore. What can be done in the case of a possible Mars impact? NASA. Under pressure. Quiet preparations begin. The mood inside NASA's Planetary Defense Coordination Office has shifted from curiosity to controlled tension. 3I Atlas is still millions of kilometers from Mars, yet its unpredictable behavior has already forced the agency to rewrite its monitoring schedule. Observatories that once checked on the object weekly were now watching it daily. The James Webb Space Telescope, the Goldstone Radar Array, and even the Mars Reconnaissance Orbiter quietly added unscheduled tracking sessions.
In addition to ground-based studies, NASA's space telescopes like Hubble, Webb, and SphereX.
Officially, it was routine observation. Unofficially, it was anything but. Internal sources described a subtle but unmistakable urgency that spreads through mission teams when data begins to break pattern. In the early days, Atlas was supposed to be stable, fast-moving, harmless interstellar visitor. But with every fresh nickel flare and each unpredicted velocity shift, the margin of certainty kept shrinking. One insider compared it to watching the ground tilt under your feet while pretending nothing's wrong. Word has it that NASA might move to a planetary contingency level 2 status reserved for events with low probability but high consequence. It isn't a public emergency protocol, but it triggers a set of behind-the-scenes responses for expanded modeling, risk communication threads with the Department of Defense, and coordination with ESA tracking stations. In simple terms, NASA was not sounding alarms. It was bracing for bad math. Supercomputer simulations began exploring dozens of outcomes. Most still showed Atlas missing Mars by tens of millions of kilometers, but a growing handful of outliers painted darker possibilities. Small changes in spin, or another one of those unexplained metal bursts, could slightly alter its trajectory, and at Atlas's enormous speed, even the smallest adjustment could push its debris cloud close enough to graze Mars's upper atmosphere. The worst-case models showed what might happen if a fragment the size of a truck broke loose and entered Mars's gravity well. Traveling at 255,000 kilometers per hour, it would strike the atmosphere with energy rivaling multiple nuclear detonations. The result wouldn't destroy the planet, but it could heavily disrupt orbiters, kick up global dust storms, or contaminate the thin Martian air with metallic particles. This is a nightmare for future missions.
It will be closest in orbit and on the surface. We'll try to catch a glimpse.
Engineers at JPL and the Mars Reconnaissance Orbiter team reportedly drafted contingency orientation instructions that could quickly reposition satellites away from potential radiation or glare spikes. No one has confirmed this publicly, but internal scheduling data suggests Mars orbiters now hold extra power reserves for unplanned observation cycles. NASA's official statements remain calm. There is no immediate threat, one press release said. Yet even within that calm, a quiet phrase keeps surfacing. We're not expecting an impact, but we're not ruling it out anymore. Privately, mission scientists describe a surreal feeling. For the first time, human technology and an interstellar object might be on a converging path. Whether that path ends in a harmless pass or a catastrophic encounter depends on variables no one can fully control. Regardless of what it is, NASA's message is the same. Track everything, prepare for anything. If 3I Atlas keeps shedding metal and drifting off course, it could rewrite not only comet science, but Mars' immediate fate. For now, all NASA can do is watch, calculate, and wait as the universe's strangest traveler races closer to the red planet. What do you think about this development? Comment down below.